So, good morning, everyone. So, last class we had discussed about probability, some basic probabilities and some numericals associated with it. And today we will be discussing on some more numericals based on probability. Okay. So, today we will be discussing on one main problem, which is card problem. Card problems. So as you know that this card has a deck of 52 card, a deck of 52 cards will be there in a packet of card. Okay, there will be 52 card in a deck of card. Okay, out of which 13 will be spade, 13 will be spade, 13 will be ace, 13 will be hearts, 13 will be diamond. These two are red in color and these two are black in color. Okay, and there will be 4. So each one will be having K, Q, J, J and W, king. 1 minute. So each card will be up to 1, 2, 3, up to there will be 1, 2, 3. There will be 13 cards in each spade, which are 1, 2, 3, up to say 10. Then we will have one king. Then there will be one ace. There will be one J. Queen, 2, 3 up to 10. There will be 10, 11, 12, 13. Okay, these are the cards. Okay, 1, 2, 3 up to 10, and there will be a king, there will be a queen, there will be a jack and an ace. Okay, there will be a king, there will be a queen, there will be a jack and an ace. 1 will not be there. Okay, 1 will not be there. 2, 3, 4 up to 10. So there are, here there is 9 and here it is 4. Sorry, here 9, 10, 11, 12, 13. Okay, 13, total 13. Like this it goes. Okay, so I had mentioned because we are doing a problem based on this card problem. Okay, so 2, 3 up to 10 and K, A, J, Q in a card. So similarly, so there will be 4 kings, 4 ace, 4 queen and 4 jack. Okay, this is the total number of procedures. Okay, total number of cards in a deck. So first we will write solve an example. So here we will consider an example. 4 cards are drawn at random from a pack of 52 cards, from a pack of 52 cards. Find the probability that they are king, queen, jack and ace. So 4 cards are chosen and four of them are king, queen, jack and ace. Second one, 2 are kings and 2 are queens. Two are black and 2 are red. Okay, fourth question is, there are 2 cards of hearts and 2 cards of diamond. Okay, and this is the basic example of a card type question. Okay, so we'll try to solve this question. Solution. So as you know that there are 52 cards are there. So here 4 cards has to be chosen from a deck of 52 cards. This is our objective. Okay, so my objective is to choose four cards from a deck of 52 cards. So first one, there shall be a king, a queen, a jack and an ace. Okay, there shall be a king, queen, jack and ace. So as I have told you, there are 4 kings, 4 ace and 4 queen, 4 jack. So out of these 4, one has to be chosen. Okay, and there are total 52 cards, out of which 4 has to be chosen. So our so we can write one king can be drawn out of 4 kings in 4c1 ways. Okay, similarly one queen, one jack and one ace can be drawn. So the required probability here, it is P of A is number of favorable cases total number of cases. Here number of favorable cases are, there are 4 kings, out of which I have to take 1 king. There are 4 aces, out of which I have to take 1. There are 4 queen, out of which I have to take 1, and there are 4 jack, out of which I have to take 1. So there are whole of 52 cards, total number of cards, there are 52 cards and I have to choose 4 cards. So it will be 4c1 is 4 into 4 into 4 into 4 divided by 52c4. So it will be 256 divided by 52c4 will be the required answer for our first step. I think the idea of card selection is very much clear to you. This is the basic idea behind the card selection procedure. Okay. If you have any doubt regarding this, tomorrow we can do one thing, and Saturday we can conduct a online meeting, so that will be fine. Coming to our next part, we have to select two kings and two queens. So there are how much kings? There are 4 kings, out of which we have to select 2 kings, and there are 2 queens, out of which we would select 2 queens. Then the required probability, so we have 4 kings, out of which we have to select 2 kings, and 4 queens, out of which we have to select 2 queens, and there are 52 cards, out of which we have to select 4 cards. Okay, 4 cards. So the required probability of B equal to 4C2 into 4C2 divided by 52C4. This is the required probability. Okay, the idea is straightforward. Okay. So the next question was, two are black and 2 are red. So there are 26 13 plus 13 26 black cards in a deck of 52 cards, and these 26 cards can be selected in, okay, how much ways? 26 C2 ways. Similarly, two red cards can be, how much red cards are there? Total of 26 red cards are there. Okay, 13 plus 13. Out of 26 red cards, you can select 2 cards. 2 cards can be selected in how much ways? 26 C2 ways. So there are 26 C2 ways, 26 red cards, out of which we have to select 2 cards, 26 black cards, out of which we have to select 2 cards, and total number of cards there are 52, out of which we have to select 4 cards. So the required probability is probability of C equal to number of favorable cases divided by total number of cases. So here it is 26 C2 into 26 C2 divided by 52 C4 is the required probability. Okay, then fourth part is, there are 2 cards from heads and 2 cards of diamond. 2 cards of diamond. So how much hertz cards are there? There are a total of how much hertz cards? 13 hertz card, out of which we have to select how much card? 2 cards. Similarly for diamonds. So there are 13 hertz card, out of which we have to select 2 cards, and there are 13 diamond cards, out of which we have to select 2 cards, and there are 52 cards in total, out of which you have to select 4 cards. Okay, so the total probability D is 13C2 into 13C2 divided by 52C4. Okay, this is the required probability. This idea should be very much clear to you, how much cards are there in each thing. Okay, I think the idea is very much clear to you. So these are some of the basic example of a card problem, and we had discussed almost every aspect of this question also. Okay. Then now we can do another question related to this. Okay. We'll do a non card problem, then we can do one more card problem because this problem is of same type. Okay, example 2. A committee of 4 people is to be appointed from 3 offices of the production department, comma 4 officers of the purchase department, 4 officers of the purchase department, 2 officers of sales department, 2 officers of sales department, and 1 chartered accountant. Find the probability of forming the committee in the following numbers. Okay, first one, there must be 1 from each department. Second one, there should be at least 1 from purchase department. There should be at least 1 from purchase department, C, the chartered accountant, must be in the committee, must be in the committee. Okay, so this is the question. We have a committee of 4 people is to be appointed from 3 officers. Let us draw a pictorial of this question. 3 officers of production department, okay, and then 4 officers of purchase department, production, purchase, then 2 officers of sales department, and 1 chartered accountant. Okay, in this way we have to select 4 persons, okay, for a committee. So our first question is, how much number of persons are there here? 4 plus 3, 7, 8, 9, 10. 10 people. Okay, there are 10 people of a committee, out of which we have to make 4 people. We have to form a committee of 4 people out of 10 people. Okay, so we will write. So we will write solution. There are 3 plus 4 plus 2 plus 1 equal to 10 people. 10 people, out of which 4 people should be formed for the committee. Okay, out of which 4 people should be formed for the committee. So first one is there must be everyone from the category. So required probability is probability of A equal to, so we can select, so there are so I will draw once again, that will be fine. 4 people from one department, 3 people from purchase department, 2 from sales department, and 1 chartered account. So this 4 person, 1 has to be selected from this 3, 1 has to be selected from this 2, 1 has to be selected, and this from 1 has to be selected, and there are 10 people, out of which 4 has to be selected. So the total number of the probability is given by number of favorable cases divided by total number of cases. So here there are 4C1 into 3C1 into 2C1 into 1 divided by 10C4. Then we know that this 10C4 is nothing but 10C4 is 10 into 9 into 8 into 7 divided by 1 into 2 into 3 into 4. So 7 3s are 21. It is 210. So the required probability P of A is 4 into 3 into 2 divided by 210. So it will be 4 by 35. Okay. The required probability 4 by 35. Next is there should be at least one from purchase department. Okay, this is the question. So there are 3 from production, 4 from purchase, 2 from sales, and 1 from one from chartered accountant. Okay, so they are saying that there should be at least one purchase, at least one. So what we will do is that in this case we will do one thing. We will say that we can say that I can consider this as probability of A or probability of B, and this probability of B can be written as 1 minus probability of there is at least one from the purchase department. So I can rewrite it as 1 minus probability of none from purchase department, because these two are mutually exclusive case. None from purchase department. So these two are mutually exclusive. At least from purchase department and none from purchase department, these two are mutually exclusive. So I can write probability of B equal to 1 minus probability of none from purchase department. So I first find out this can be find out, but അത് പിന്നെയും എഴുതി കൊടുക്കേണ്ടി വരും. X equal to 1, X equal to 2, X equal to 3 എന്ന് പറഞ്ഞിട്ട് അങ്ങനെ എഴുതുന്നൊരു എക്സാമ്പിളും കാണിച്ചു തരാം. Okay, so none from purchase department. So we can do one thing. What is the probability that none forms from a purchase department? So if this 4 persons are not there in the purchase department, first we find out probability of none from purchase department. So here we see that we exclude that 4. So here we have only 3, 2 and 1. Okay, we exclude that 4. So since we are not taking that 4, so there are 3 plus 2 5 6 people, out of which we have to select 4. Okay, we have to select 4. Okay, so the required probability is probability of none from purchase department equal to 6C4 divided by how much people are there? 210 10C4. There are total of 10C4 people. Okay, 6C4 is 6 into 5 divided by 1 into 2 divided by 210. This we had find out earlier. So it will have 15 by 210. It will be in going, so it will be 1 by 14. Okay, Okay. So this is not our answer. This is the probability that none from the purchase department. None of them will be from the purchase department. So our question is, there is at least one from purchase department. Purchase department equal to 1 minus this probability, 1 by 1 by 40. Okay. This is the basic idea. So it will be 13 by 14. There is a high probability, 13 by 14. Okay. That at least one from purchase department. Next question. One more part of this question. Third one. There are. What was the question? The chartered accountant. The chartered accountant must be in the committee. The chartered accountant must be there in the committee. So the chartered accountant should be there in the committee. So there are how much people? 3, 4, 2, 1. So this should be fixed. Okay. So this should be fixed. This one should be fixed. So the remaining, there are how much people? 4 plus 3, 9 plus 9 people. And how much? 3 has to be selected, because this one is already fixed. Okay. So there are 9 people, out of which we have to select 3, since 1 is fixed. Okay. So how much people are there? Out of 10 people, we have to select 4 people. Okay. So this is the basic idea. Okay. If you draw a picture, then it will be very much clear to you. So there are 9 people, out of which we have to select 3 people. This one is very much fixed to you. It is fixed. Okay. So we will write favorable number of cases that the CA chartered accountant as a member and 3 others from other committees are 1 into 9C3. This is the thing, 1 into 9C3. Okay. Since a chartered accountant can be selected out of 1 chartered accountant. So the one chartered accountant should be selected out of because there are one. If it was 2, then it will be 2C1. Okay. Since there was only 1, we will write it as 1. Okay. 1 chartered accountant. Okay. then the remaining, so we have to select 4, so 1 is selected, the remaining 3 people or remaining 3 members can be selected out of this 9 people in 9C3 ways. So probability of C equal to 9C3 into 1 divided by 10C4. Okay, this is the probability. So 9C3 is 84, then T210. Okay, this is the answer. It will be 2 by 5. 2 by 5. Okay, this is also an example. Next we will consider one earn problem. An urn contains 6 white balls, 4 red and 9 black balls. If 3 balls are drawn at random, find the probability that 2 of the balls are white. Second one, 1 in each color. C, at least one white, none is red. None of them are red. D, none of them are red. D, at least one is white. One is white. This is the question. Okay. So this is the question. So we will address this problem. Before that, we will draw a graphical picture of this problem so that it will be easy for us to answer. So there are 6 white balls, 4 red balls, then 9 black balls. Okay, 9 black balls. So how much balls are there in total? There are 6 plus 4, 10, 19 balls. And out of this 19 ball, we have to select how much balls? Random. 3 balls should be drawn at random. Okay, 3 balls should be selected. This is the basic idea or the basic picture. Okay, so our first question is probability that 2 of them are white balls. If 2 of them are white balls, then there is only 1 ball from this section. Okay, so we can have if 2 balls of the 3 are drawn from white, then these 2 balls should be drawn out of 6 white balls, which can be done in 6 C2 ways, and the third ball can be drawn in such a way that it is 9 plus 4, 13 balls selected from 1. Okay, that is here we have 6 balls, out of which first question 2 of the balls 2 of the balls are white. Okay, so here 6 white balls, we have to select 2 balls. Okay, it can be done in 6C2 ways. Okay, then here combinedly we get 13, out of which we have to select 1. Okay, so it can be done in 13C1 ways, and total of there are 19 balls, out of which we have to select 3 balls. So it can be done in this much number of ways. If you draw the picture, it will be very much clear to you. 6 balls, out of which we have to select 2. Then we have to select only 1 ball left. So out of this 13 balls, we have to select 1 ball. And there are total number of 19 balls, out of which we have to select 3 balls. So the required probability is this one. Okay. Next question, we will draw that graph once again so that it will be easy for us to understand. So there are 6 balls from this and 4 balls from another section, from 9 balls, total 19 balls, out of which we have to select 3 balls. Okay. Our next question is, what was our next question? One is in each color, one from each color. So this is very simple. We have to select from 6. It is 6 white balls, 4 red balls, and 9 black balls. So from 6 white ball we have to select 1 white ball. From 4 we have to select 1, and from 9 we have to select 1. So the total probability will be probability of B equal to 6C1 into 4C1 into 9C1 divided by 19C3. Okay, so basic idea. Okay, next question we can do. Okay, next part. None is red. So in this question we have that 6 white and 4 red and 9 black. So we have 19, from out of which we have to select 3. This was the question. So here we do not consider this 4 red. None of them are red. So we have to find out the probability that none of them is red. Okay. So what we will do? So 9 plus these two combinedly we get it as how much? 15 balls, out of which we have to select how much balls? 3 balls. So probability of C equal to 15C3, then total number of ways is 19C3 is the required probability. Very simple. Okay. Then one more question. Probability that at least one ball is white. So I take it as earlier question, 1 minus probability of none of them white, none of them are white, none of white, or none of them are white. So first I find out what is the probability that none of them are white. What is its probability? Okay, first I find out that. So there are how much? 6 white balls, 4 red balls, and 9 black balls. Total of 19 balls, out of which I have to select 3. So here I am saying that this 6 is not there, so I cross off this. So there are 13 balls, out of which I have to select 3 balls. Okay, so probability of none is 13 C3 by total number 19C3. Okay. Okay. And then probability of probability of at least one white ball. 1 minute.